those two cyanides have been considered pretty non-toxic, and so they can add them to the drinking water and have for 100 years. They were discovered about 200 years ago, these two cyanides, because they can give a most lovely blue color, and people like to have their laundry blued. And when you buy a detergent, you'll find little blue granules in it, because people like their detergents and soaps blued. And it isn't all the ferrocyanide, but there is a dye called methylene blue, which can change ferry to ferro. So that did take up the last few years. And the bottom line is that all the people with cancer are drinking ferrocyanide plus polonium. And the others are drinking ferricyanide without methylene blue and without polonium. Should I go over that once more? Okay. The bleaches used to chlorinate water are quite complex. Although the law doesn't want anything added to potable, namely drinkable water, it does require disinfection, and chlorination is the cheapest, most efficient way that we have had in the last 100 years. We have enjoyed Salmonella-free water, E. coli-free water. We've enjoyed the good health that it has made. But certain chemicals have sneaked in that we all thought were safe, and they sneak in strange ways, like you putting a filter on your system, which isn't the city's responsibility, but it's a part of the system that isn't studied, therefore. The only person who could study it would be myself, where everybody was bringing a number of water samples. And so the water that cancer patients are drinking is very different from the water that the non-cancer patients are drinking. And the difference is subtle. We're putting more and more filters on our water system, trying to purify it, and thereby actually introducing our cancer. There is no exception in thousands of cases, not one exception. There were no there was no water that was missing one of those, and there was no water that belonged to the other category. So it's an absolute proved theory. So the first thing we did was switch everybody, of course, off the chlorinated water, and we drink well water. That's how we start our cure process. Now, why would we want to remove the chlorinated water that doesn't have the polonium? Because that other cyanide that I'm seeing relatively good actually causes all our other diseases. And that's what I came to talk about from Mexico today. So take a look at the 11th page, the 11th concept, right in back. Now, because all this is about polonium, which is a radioactive element, obviously we have to know something about radioactivity, and it's not nearly as difficult as you might think. But to do this, we need to just take a look at the basics about radioactivity that you'll find on page 8. If you would turn to page 8, please. Up on the top, it says the radon chain. All of our radioactivity that we have on this planet starts out with uranium, which was here in the beginning of time, which is 4.5 billion years ago. And uranium likes to react with phosphates. And so as the Earth cooled down, the uranium, called uranium-238, the heaviest one of all of our elements, combined with phosphate and hardened. If you leaf over to the next page, page 9, you see where it is now. It's just under the surface of the Earth, sometimes deep, sometimes shallow, and there you see the uranium phosphate rocks. We're living on top of that. And obviously, little pieces keep coming off and managing to reach the surface, and then they take a little ride on a dust particle and a bit of air riding on its little blanket, magic blanket of sorts, or demonic, and sails up. And if you happen to build your house right on top of that, it sails into your house and through your house, just like this, along the air currents. But remember, I said that every person with cancer had to drink this particular chlorinated water. We do not get our cancers from the uranium that we're living on top of.
Does that include distilled water also? Because I've had cancer, and I was drinking distilled water, and I thought that was the cure.
I'm going to answer all those important questions this afternoon. Okay, so keep your list. They're very important because all of this has to make sense and be something doable for you. So first I want to explain how this happens, and so that I can talk to you about it, we have to understand what radon is, what polonium is, and what uranium is. So uranium starts it all at 238, but it isn't stable, it's just too heavy a molecule. So it breaks off a little piece called alpha. And that little piece always is the same, and it weighs 4 grams out of that, and then you can see right under uranium-238, you see something that weighs only 234, because it lost a little particle called an alpha particle. This alpha particle can get through your tissues and cut right across a chromosome. And that is what we see a lot of in cancer and in certain other diseases. And then it continues to decay because it's still not stable. And first it gives off an alpha particle, then an electron called a beta, and then another electron called a beta, and then another alpha. Do you see that? You follow with me? We're on page 8. And then you get to radon, Rn. And radon gives off an alpha particle too. But radon is a gas. So in its progression through this decay process, a gas is formed. And that's what is so hazardous to you. And of course, uranium is hazardous to you because it's going to make radon. So on these little dust particles that are coming up into your house, and get trapped in bottled water. All bottled water has radon because it's happening everywhere on Earth. Maybe not absolutely everywhere. Maybe the Earth is deep enough in some places to where it doesn't come up there. I don't know that, but those studies have been done and you could find them on the internet. So, but radon doesn't cause your cancer either, right? It's in the water, in the chlorinated water, that particular chlorination. And if you want to bring a sample of yours this afternoon, we'll be testing quite a few waters so you can see the reality of it. Going down to the periodic table of elements, on the same page, 8, look way down at the bottom where the heavy elements are. Look at number 84, that little square where it says PO. Okay, that's where polonium is. It's right up there with the radioactive elements. And when things decay, they get lighter and you go to the left. Go all the way to the left to an element called La for lanthanum. There are actually 15 elements that belong in that little square because they all behave the same way. They're called lanthanides. I talk about that quite a bit in my books because the lanthanides are magnetic and they have a strange way of influencing your DNA. So whenever you have a lanthanide in an organ, the DNA is on for a longer time. DNA is what multiplies our cells, and to have it on more than normal is quite a bad idea. None of the lanthanides are used in biology. If you look at that, further down where it says lanthanides, you see a set of 14 of them. They all belong together in that one little square called lanthanides, and at the very left end is Ce, which is cerium. Underneath that, the actinides are the radioactive ones, and the lanthanides are not radioactive except for one called promethium. Find promethium. It's not far from cerium. Okay, can you find those two? Cerium and promethium. Okay, now turn the page to page 9, and you'll see what I've been talking about. The dust particles coming up with all the elements of the world attached. And if you want to search for this yourself, because it's kind of unbelievable, you can do this simple experiment. You can use this kit that I'm talking about, called this 201 lab kit, and that's what I'm going to be demonstrating this afternoon. If you hang up a piece of paper towel, just from a coat hanger, and you wet it, just dampen it a little, you let it hang for about 5 or 10 minutes. Then you can stuff it in a plastic bag and put it on this device, and you'll find every element on this planet is on there.